Rates, patterns, and problem solving. Welcome to algebra. Algebra is about properties of numbers, how they behave, and so you're able to manipulate them. And the unknowns are the variables. Today we're going to talk about rates and ratios, things that you are familiar with. You have seen this stuff before in 6th and 7th grade. So let's start off with this first one. Answer the following rate ratio question using multiplication and division. So it also reminds us to keep track of our units. So if there are 12 eggs per carton, then how many eggs do we have in 5 cartons? So that's going to be a multiplication. So we should end up with 60 eggs total. Okay, using multiplication there. Part B says if a car is traveling at 65 miles per hour, then how far does it travel in 2 hours? So I might choose to do a little division on this one just because something a little bit different. So 65 miles every hour. I got miles on top, hours on the bottom. So they want to know how far does he travel. So we're looking for the miles. I'm going to call that X divided by 2 hours. Doing a little cross multiplying there, we end up with 1 times X, which is just X. And then 2 times 65 gives me 130 miles. Okay. Not going to do C, but I will give you the answer. 2 slices per person. And letter D, it says if a biker travels 20 miles in 1 hour, how many minutes, okay, we're changing up the units there, does it take per mile traveled? So if I start off with 20 miles on top, I don't want to go hours on the bottom because I need to get my final answer in terms of minutes. So just convert that 1 hour, we know is 60 minutes. So miles to minutes equals 1 mile to how many minutes? So if we, again, do that cross multiplying, 20x equals 60. We divide by 20. And we end up with 3 minutes. Down on number 2, this is where I think it gets a little bit more interesting because we've got some application to it. It says a runner is traveling at a constant rate of 8 meters per second. How long does it take for the runner to travel 100 meters? How long? So we're looking for time. We know distance and we know rate, how fast the person is moving. Great way to sort of track this is to put things in a table. Tables can tell us a lot. They can help us organize our information, and it's a little bit easier to start to see patterns. So after 1 second, how far has this person run? They have run 8 meters because they're 8 meters per second. Every second they're running 8 meters. So at 2 seconds, we're at 16 meters, 2 times 8. 5 seconds, 5 times 8, 40 meters. And then 10, we are at 10 times 8, which gets to 80 meters. So create an equation that gives the distance d that a person has run if you know the time t they have been running. So distance equals the rate that this person is running at, 8 meters per second, times the number of seconds. That's going to give us our total distance. Now we're going to use that equation. It says, based on part B, that gives the exact amount of time. So again, we're looking for a t. It takes for the runner to travel 100 meters. So that 100 meters is our distance, equals, our rate is 8. We're looking for the t. So divide by 8 to solve for t. We end up with t equals 12.5. And what are our units? seconds. Exercise 3 says a man is walking across a 300-foot long field at the same time his daughter is walking towards him from the opposite end. The man is walking at 9 feet per second, and his daughter is moving a little bit slower, 6 feet per second. They will meet somewhere in the middle. So key information, a 300-foot long field, and then the rates at which both of those people are moving. So let's focus in on the father just for a second. And after 1 second, okay, his unit rate is 9 feet. So then after 2 seconds, 2 times his rate, 18. 5 times 9. 10 times 9. I'm going to expand this a little bit, and I'm going to say, okay, well, what about after 15 seconds? How far? So 15 times 9, 135. And maybe let's jump up to 20 seconds. 20 times 9, we're at 180. Now let's look at the daughter's distance. So after 1 second, it says 6 feet per second. So we have 6. 2 times 6 is 12. 5 times 6, okay, it's that constant rate times time. And we end up with 30. 10 times 6. And let's do the same thing over here for the daughter. That 15 times 6. And we end up with 290. I'm sorry. 90, and then 20 times 6, and we are at 120 feet. So now let's talk about the total distance that they've traveled together. So 9 plus 6, we've got 15 feet, 30 feet, 75 feet, 150 feet, 225 feet. There's our total over there. And now we're at 300 feet. Remember, we keep adding the father plus the daughter's distance. There's that magic number of 300, which was the length of that field. So they've covered the entire length. It says, what must be true about the distances the two have traveled when they meet somewhere in the middle? State any observations that you think are relevant to modeling this problem. Well, we need to think about we have a total of 300 feet to travel, and the father is moving faster than the daughter. Okay, he is moving at 9 feet per second, and she is moving at 6 feet per second. Create equations similar to that in exercise 2 to predict the distance the father has traveled and the distance the daughter has traveled. So the father, if we keep in mind that distance equals rate times time, distance equals, he was moving 9 feet per second. So 9 times the time that he's traveled. And the daughter distance equals her rate was 6 feet per second. So 6 times t. Create and solve an equation to predict the exact amount of time it takes for the father and daughter to meet in the middle. So father's distance plus the daughter's distance equals the total distance of 300. Combining like terms, we end up with 15t equals 300. To solve for t, we're going to divide by 15, and we end up with 20 seconds. If you'd flip past the next couple pages, to come up to the next lesson, variables and expressions. Let's get right into this one. So what is an expression? Right? An expression, right, is any combination of numbers that we know and ones that we don't, variables. Okay, so numbers and variables make up an expression. So let's review the order of operations. And order of operations, you should it should come to mind, PEMDAS. Okay, parentheses, exponents, multiplication, division, addition, subtraction. And do these without a calculator, okay, in order to review those basic middle school concepts, meaning the stuff that you did in 6th and 7th grade. So that first one, multiplication and addition, I'm going to say is 6 plus 7, which gives me a final answer of 13. Letter B, all right, I'm going to look, sort of scan it, and I'm going to say, okay, I'm going to need to do that multiplication. I'm going to need to do that division. So I'm going to say, what is negative 1/2 times a positive 6, which is negative 3, plus 24 divided by 6 is 4. Now just go from left to right. So 8 minus 3 is 5. 5 plus 4, 9. This one we've got some parentheses. So 4 times 2 minus 7 times 2. Now let's do that multiplication. 8 minus 14, negative 6. Letter D, we bring in some exponents and no parentheses. So let's go right to those exponents. 25 minus 16 plus 3, all over that 1 minus 5. Now I'm going to evaluate that numerator first. 25 minus 16, okay, plus 3. 25 minus 16 plus 3 is 12, divided by negative 4, which gives me a final answer of negative 3. And in E, go over those parentheses, negative 5 times 2, and then we have some exponents, plus 9, negative 10 plus 9, negative 1. You want your mental math skills to be real strong doing these. Okay. Negative 16 divided by 2. Wow, we've got a fraction and a fraction, and we've got something raised to the third power. So I'm going to sort of get rid of that fraction within the fraction. So negative 16 divided by 2 we know is negative 8. And then we've got this multiplication here. Plus 5 times 2 is 10, divided by, and then 2 to the third power means 2 times 2 times 2, which is 8. And then taking care of that numerator, I end up with 2/8, which we know simplifies to 1/4 or 1/4. Okay. So now in exercise 2, it says, if the letter X represents some unknown quantity, explain the calculation that each of the following expressions involving X represents. So we're explaining what's happening here, this 3X minus 8. So what would we do? We would multiply 3 by X, or X by 3, then subtract 8. Okay. Part B, we would subtract 4 from X, okay, and then we would divide by 2. What would we do in C? We would say X is first squared, okay, or multiplied by itself, then multiplied by 4, and we would subtract 8 from it. Okay, flip the page. So it says if you can read an algebraic expression, okay, one that contains variables, then you should also be able to evaluate. So we're going to find the value. So evaluating expressions, finding the results of the calculations, okay, to evaluate finding the results of the calculations of an expression when all variable values are known. So in 3a, it says evaluate 4x minus 7 when x is 5. First, explain what the calculations are occurring in the expression and then find its value. So we're saying 4 times a number x. Whoops, I don't know where that big purple line came from. Take away 7. So that's what's occurring. So now let's do, if we know that x is 5, 4 times 5 minus 7. So order of operations says 4 times 5 is 20 minus 7, which leaves us with a value of 13. Okay. Let's look at that next calculation. So we have 8 minus 2 times negative 3 squared. Always put your negatives in parentheses, your negative numbers in parentheses when you're doing your substitution. Be real careful of that. So order of operations tells me I'm going to do this exponent, negative 3 squared, which is a positive 9. Then I'm going to do 8 minus 18, okay, which gets a negative 10. Okay. And letter C, let's substitute in that negative 2. So 2 times negative 2 plus 8. Just doing the substitution, plus 3 plus 1. Let's show all our steps here. Order of operations, we've got to do what's inside the parentheses first, divided by 3 plus 1. Then I'm going to say 2 times 6, which is 12, divided by 3 plus 1. 12 divided by 3 is 4 plus 1 for a final answer of 5. And last but certainly not least, we've got a nice little trinomial here. We're substituting 4 in. Wow, lots happening. We've got some fractions, some exponents. So 1/2, that 4 squared is 16. I might go ahead and save myself some time, and I would multiply that out. Minus 8 minus 3. Go back here. What's 1/2 of 16? 8 minus 8 minus 3. 8 minus 8, 0. We're left with negative 3 for our final answer.